Section 5.1. Simplifying rational numbers and rational expressions. What is a rational number and what is a rational expression? By definition, a rational number is a number that can be written as a quotient of integers, basically a fraction. Rational expressions is the quotient of polynomials. A rational expression can be written in the form of p over q, where p and q are polynomials and q does not equal 0. Find the numerical value of x minus 3 over 5x plus 1 for the given value. A, x equals 4. So what are you going to do here is basically wherever you see an x in the expression, you're going to substitute in, using parentheses, the number 4, and you're going to perform any arithmetic operations to complete the solution. So at the bottom you see here we have 5 being multiplied by 4. That's the first thing that you should do. So if you did so, you'll have 4 minus 3 at the top over 20 plus 1 at the bottom. And of course 4 minus 3 is just 1, and 20 plus 1 is 21. And that will be your answer, and you cannot reduce that any more than that because there's nothing that goes into both 1 and 21 other than 1. So therefore that's your simplified answer. Suppose x equals negative 3 this time. Same principle, same concept. In this same expression, we're going to substitute in for the value of x, negative 3, and we're going to perform any operations arithmetically. So therefore at the bottom, once again, we're going to perform the multiplication. So at the top we'll have negative 3 combined with the negative 3, and at the bottom 5 times negative 3 is negative 15 added to 1. So we're going to have negative 6 over negative 14. Why negative 6 in the numerator? Because both negative 3 and negative 3 have the same sign, so you add and keep the common sign, so that's a negative 6. And why negative 14 at the bottom? Because negative 15 combined with the positive 1, because of the unlike signs, will give you negative 14, because you would subtract and keep the sign of the larger number. However, 6 over 14 does reduce by the number 2, and if you did so, would give you a result of 3 over 7. Suppose x equals 1. Same process, same expression, but this time we're going to substitute in 1 for the value of x. And just as in example A and example B, we're going to do the same process in example C. Perform the arithmetic operations and then simplify. So we're going to multiply 5 times 1. So in the numerator we'll have 1 combined with a negative 3, and 5 times 1 being 1. Sorry, 5 times 1 being 5. So now we have 1 minus 3 over 5 plus 1, which is negative 2 over 6, which reduces down to be negative 1/3. Identify when a rational expression is undefined. A rational expression is undefined for values that make the denominator equal 0. To find these values, we must set the denominator equal to 0 and solve for the given variable. Note, if the denominator does not have a variable in it, then there is no number that will make the denominator undefined or equal 0. Example, are there any values for which the expression is undefined? Here, the first expression is x divided by x minus 3. So what we're going to do first is set the denominator equal to 0. So take x minus 3, set it equal to 0, and then solve for x. So therefore we're going to add 3 to both sides. X is equal to 3. Example B, this is a trinomial. So therefore we take x squared minus 3x plus 2, which is the denominator, set it equal to 0. Because this is a trinomial and it's the BC method, this is very easily factored. So we can go ahead and break down our parentheses. and we will find that our numbers are -2 and -1. Remember, the BC method says the two numbers must give you a product of C. C in this case is a +2, but they must give you a sum of B, which in this case is -3. -2 times -1 is +2, and -2 added to -1 is -3. Set the factors equal to 0, and then solve for x. So add 2 to both sides on this factor. X equals 2. Set this factor equal to 0. Add 1 to both sides. X equals 1. Now here in example C, as you can see, there is no variable in the denominator. Therefore, there is no number that will make this denominator undefined. Simplifying rational expressions. Simplifying rational expressions is doing something we've done in the previous chapters, and that's reducing the expression down into the lowest terms. In this section, we'll be reducing rational expressions by factoring them and reducing if possible. Remember, the variable typically is written first in an expression. If the variable is not, then rewrite the expression so that it is written first. Be aware of the -1 factor rule. You are not allowed to leave a variable negative. To change it into a positive, factor out a negative. 1 with therefore changes all signs of the remaining terms. Here is the first expression, 5x minus 5 divided by x to the third minus x to the second. Here in the numerator, you should notice that 5x and 5 has a GCF of 5. So if you take out a 5, you'll be remaining with something left over. Likewise, in the denominator, you should notice that the GCF for x to the third and x to the second is x to the second. So if you take out a 5 from the numerator, factor out a 5, if you will, you're left with x minus 1. If you take out x squared in the denominator, you're left also with x minus 1, which if you notice, the x minus 1 cancel out, leaving you with a result of 5 over x squared. Here you have two trinomials which are in the BC method format. So therefore they're going to factor very easily. Okay. X to the second plus 11x plus 18 factors to be x plus 9 and x plus 2. And x to the second plus x or 1x minus 2 factors to be x minus 1 and x plus 2. If you notice, the x plus 2's cancel, leaving you with the result of x plus 9 over x minus 1. In this example, you have a trinomial in the numerator, but a binomial in the denominator. So in the numerator is the BC method, which factors very easily. Once again, it's going to be x plus 5 and x plus 5. However, the denominator has a GCF of x. Therefore, if you take an x from those two terms, you're left with x plus 5, which means one set of x plus 5's cancel out. Not all of them. Be careful of that. So therefore, you're left over with x plus 5 divided by x. Example D, m to the second minus 81 divided by m plus 9. You should notice that the numerator is what's known as the difference of squares. So that factors very easily to be m minus 9 and m plus 9 all over m plus 9. If you notice, the m plus 9's cancel out, leaving you with a result of m minus 9. Simplify each expression. Once again, same principle, just more examples. There's not much you can do with the numerator. However, the denominator is the difference of squares. So therefore, it factors very easily. So therefore, we have x plus 5 over x plus 5 times x minus 5, which means the x plus 5's cancel. Now, because the x plus 5 cancels out completely from the numerator, we must put something in its place, and that number will be the number 1. So therefore, we have an answer of 1 over x minus 5. Example B, x plus 4 over 4 plus x basically becomes x plus 4 over x plus 4, which equals 1. It's the same thing essentially. So taking an expression and dividing it by itself, it just becomes 1. Here, x minus 4 divided by 4 minus x. Now be careful, this is not exactly like example B. It does appear that these two are the same, but they're actually not. If you rewrite this, it becomes this. In the denominator, you can factor out a negative 1, which will change the signs. And if you notice, the x minus 4's cancel out, leaving you with the result of negative 1. Section 5.2, multiplying and dividing rational expressions. Multiplying rational expressions. If p over q and r over s are rational expressions, then p over q times r over s equals pr over qs. Basically, when you multiply rational expressions, multiply the numerators together and multiply the denominators together. Example, multiply. 16y over 3 times 1 over x squared becomes 16y over 3x squared. Remember, reduce a fraction if you can. However, this fraction does not reduce, so therefore we leave it as it is. This example, if you multiply straight across, you will get negative 10a to the third b to the second over 45a b to the third. This can be simplified because both 10 and 45 are reducible by 5. And remember, when you are dividing variables with the same base, same letter, you subtract the exponents. Well, if you reduce 10 by 5, you're left with 2. And if you reduce 45 by 5, you're left with 9. 1a from 3 a's leaves you with 2 a's. And if you take 2 b's from the top, from the 3 b's at the bottom, you're left with 1 b at the bottom. Multiply. Here we're not going to physically multiply, but we're going to factor and see if we can reduce. So let's take a look at the numerator of the first fraction. 3x and 6 have a GCF of 3 in common. And let's take a look at the denominator of the second expression, and those two terms have an x to the second in common. So if I factor that information out, what I have is 3 parentheses x plus 2 over 14 times 7x to the second divided by x to the second times x plus 2. The x plus 2 is canceled out, and you're left with basically, as well as the x squared is canceled out. So you're left with 3 over 14 times 7 over 1. Now there's a 1 down there because everything in that denominator canceled out. Remember, when that happens, replace it with the 1. Here, just perform the multiplication. 3 times 7 is basically 21, and 14 times 1 is 14, which both of these numbers are reducible by 7. And if you did so, will give you an answer of 3 over 2. Same example, same process. The numerator of the first fraction has a GCF of x in common, and the denominator of the second expression has a 5 in common. So therefore, if I factor x from the numerator of the first fraction and factor out a 5 from the denominator of the second fraction, I will get this. X times x plus 1 over 3x times 6 over 5 times x plus 1. The x plus 1's cancel. Also, you'll notice the x's cancel. So therefore, since everything in the numerator of the first expression canceled out, we replace it with the 1. So now we have 1 over 3 times 6 over 5, which is 6 over 15 if you multiply. However, this reduces both of them by 3 to give me a result of 2 over 15. 2 over 5, I'm sorry, 2 over 5. Simplify. Now, this expression, the numerator is the ABC method. However, the denominator is the difference of squares. So therefore, we're going to pull the numerator off to the side and factor it using the AC method. The numbers are going to be a positive 1 and a negative 6. Which, of course, remember the ABC method always turns into factor by grouping. So therefore, since we found our numbers, it creates 4 terms, which means we're going to group them. And we're going to begin factoring. The first 2 terms have an x in common, which means if I divide by x, I'm left with 3x plus 1. The second 2 terms have a 2 in common, and if I take that out, I'm left with, once again, 3x plus 1. The binomial is in common, which is 3x plus 1, so if I factor that out, I'm left with x minus 2. So my numerator of this expression is 3x plus 1, x minus 2. However, the denominator is the difference of squares, so that factors as in 3x plus 1, 3x minus 1. This cancels out. The 3x plus 1s cancel out, as you can see, leaving you with the remainder of x minus 2 over 3x minus 1. Dividing rational expressions. If P over Q and R over S are rational expressions, and R over S is not 0, then P over Q divided by R over S equals P over Q times S over R, which equals PS over QR. Basically, when you divide rational expressions, multiply the first rational expression by the reciprocal of the second rational expression, a process we've seen before called copy, change, flip. Example, divide. 7x to the second over 6 divided by x over 2y. Copy the first fraction down, change the division sign to multiplication, flip over the second fraction, and perform the multiplication. You see here you're going to get 14x squared y over 6x, which can be reduced to 14 and the 6, as well as you can simplify the x exponents. If you did so, 14 is divisible by 2 as well as 6, and if you take 1x from the 2 you have at the top, you get a final result of 7xy over 3. Here once again, x minus 4 to the second power divided by 6 divided by 3x minus 12 divided by 2. Once again, we apply the copy, change, flip process. So we copy the first fraction down again, change the sign from multiplication, from the division to multiplication, I'm sorry, flipping over the second fraction. Now, if you remember from previous chapters, x minus 4 to the second power is shorthand for x minus 4 times itself twice, times the right hand side. Now, if you notice, the bottom denominator of the second fraction has a GCF of 3 in common. So if you take that out, you're left with x minus 4, which if you notice, there's some simplification that can be done here. So the x minus 4s cancel out, at least one set of them. We can also do a little method called cross reduction, because I noticed that 2 can go into itself once, but can go into 6 3. So now I'm left with x minus 4 over 3 times 1 over 3. If you want to expand this, you have x minus 4 over 3 times 3 is 9. Once again, this is a bigger expression, but it can be done the same way. We're going to apply the copy, change, flip method here. So we're going to copy, change the sign from division to multiplication, flip the second fraction, and we're going to begin to simplify by factoring. The numerator of the first expression has a GCF of 2 in common, so I can take out a 2. As well as the denominator is known as the difference of squares, so that factors very easily. The denominator of the second expression has a GCF of x squared in common. So if I factor that out, if I factor all this information out, I'm left with 2 times 5x plus 2 over x minus 2 times x plus 2 times x plus 2 over x squared times 5x plus 2. And there's a couple things that simplify here. I can cancel out the 5x plus 2's. I can also cancel out the x plus 2's. Now remember, because the numerator of the second fraction cancels out completely, we will replace a 1 there. So now we have 2 over x minus 2 times 1 over x squared. And if you want to take it a step further, you can do the multiplication straight across, 2 times 1 being 2, and you can simply connect the denominators of the two bottom expressions as is, as shown, as you can see. Or if you choose to go even further than that, you can actually multiply x squared all the way through in parentheses if you choose to do so. Section 5.6, Ratios and Proportions. Writing ratios as fractions. By definition, a ratio is the quotient of two numbers or two quantities. A ratio, in fact, is no different from a fraction, except that a ratio is sometimes written using notation other than fractional notation. The ratio of a number A to a number B is their quotient. Ratios can be written in the following ways. Also see the examples on the next slide. A to B, A colon B, and A divided by B. These are all the ways you can write ratios as fractions. Write a ratio for the following phrase. The ratio of 2 parts salt to 5 parts water. Well, that's simply salt divided by water. So we have 2 divided by 5 because we have 2 parts salt and 5 parts water. The ratio of 18 inches to 2 feet. That will be inches to feet. Now, we need to convert 2 feet into inches. To do this, we're going to multiply 2 feet times 12 inches because if you have to remember from early in your educational career, certain measurements are equivalent to certain measurements. 2 feet is equivalent to 24 inches because remember there are 12 inches in a foot. So if you do 2 feet times 12 inches, that's a total of 24 inches. So now we have everything in the measurement of inches. So now we have 18 divided by 24, which both of them are reducible by the number 6 to be 3 over 4. Solving proportions. Proportion is a mathematical statement that two ratios are equal or the left side ratio is equal to the right side ratio. To solve proportions, we use what is commonly known as cross product. See the format below and the examples on the next slide. If A divided by B equals C divided by D, then A times D equals B times C. First example, 3 over 8 equals 63 over x, and you're asked to solve for x here. So if we apply the cross product method, then I will be basically multiplying 3 times x and setting that equal to 8 times 63. Perform the multiplication. 3 times x is 3x, and 8 times 63 is 504. In order to solve for x, divide both sides by 3. x is equal to 168. Solve for x. X minus 5 divided by 2 is equal to 2x plus 3 divided by 5. Once again, we will apply the cross product method. So therefore, we're going to multiply 5 times x minus 5. Set that equal to 2 times 2x plus 3. We're going to distribute everything on the left hand side will be multiplied by 5, and everything on the right hand side will be multiplied by 2. 5x minus 25 is the result, equals 4x plus 6. Begin solving for x by subtracting 4x from both sides of the equal sign. X minus 25 equals 6. And then add 25 to both sides to finally solve for x. Therefore, x is equal to 31.